This is the normal distribution, part 4. We were on example 3, where we were finding the area under the standard normal curve that is between whatever boundaries were given in these 4 parts. We're on part 4. We want to find the area under the standard normal curve that is outside the interval between z equals 0.44 and z equals 210. Okay, so I've drawn the standard normal curve. We want to know the area that's outside the boundaries, negative 0.44 and 2.10. Now we want to find the area outside. So we want to find the area on the outside, so the area to the left of negative 0.44 and the area to the right of 2.10. And there's actually a couple different ways that you can try this. So one way would be to find this area. So the area normal CDF from negative infinity to negative 0.44. And then do it again and find the area normal CDF from 2.10 to infinity, and then add those two together. Another way to do it is taking what we know about the probability density curve. We know that the entire curve is 100% or 1. So we can find the area here in between this and this boundary, between negative 0.44 and 2.10, and we can subtract that from 1, and that will give us these outside portions. So we can just do 1 minus normal CDF negative 0.44, comma 2.10, comma 0, comma 1. So again, we're finding this area inside here, subtracting that from 1, and that gives us the area on either side. Okay? You can type the whole thing in the calculator from the 1, the minus, the normal CDF. So 1 minus normal CDF, so that's second vars number 2. The lower boundary is negative 0.44. The upper boundary is 2.10. Mean is 0. Standard deviation is 1. Paste. And that gives us 0.3478. Okay. Let's look at example 4. The normal distribution has a mean of 20 and a standard deviation of 4. So before we were using the standard normal curve, now we're just using a regular normal curve where the mean is not 0. The standard deviation is different than 1. So what proportion of the population is less than 18? So remember, when they ask for proportion of the population, we can find that by finding the area of the curve with the boundary for being less than 18. So if we draw out our normal curve and we label our mean is 20, our standard deviation is 4, we're going to find 18. Now 18 is somewhere along here. Again, doesn't have to be perfect. We want to shade less than 18. So we've shaded that direction. So our boundaries are negative infinity to 18 for our left and right boundaries. So we're going to do normal CDF. Left boundary is negative 1e 99. 18 is the upper boundary. The mean is not 0. The mean is 20. And the standard deviation is 4. So let's pull the calculator up for that. So second vars, number 2, left boundary is negative 1, second comma for e, 99. The upper boundary is 18. The mean is 20. The standard deviation is 4. And we get 0.3085. 0.3085. Okay, so that one asks what's the proportion. So we already said proportion is the area underneath the normal curve. Well, this one says what's the probability. that a randomly chosen value will be greater than 25. So again, we go back to finding the area under the normal curve. So here's the normal curve again, with the mean labeled as 20. Standard deviation is still 4. We want the value that's greater than 25, so here's 25 about here. Greater would be in this direction. So the left boundary is 25. The right boundary keeps going on forever, so that's infinity. So we're going to do normal CDF. The left boundary is 25. The right boundary is positive infinity. Mean is 20. Standard deviation is 4. So in the calculator, second bars, number 2, 25 is the lower boundary, 1 second comma, 99 is the upper boundary, 20 and 4.1056 is the probability. Okay, 0.1056 is the answer. So that's about the probability that a randomly chosen value will be greater than 25 is about 10.56%. Alright, so now we have example 5, pregnancy lengths. The average length of pregnancy is 272 days and a standard deviation is 9. Find the probability that a randomly chosen pregnancy will last less than 252 days, that it will last more than 252 days, or that it will last between 252 to 298 days. So 3 questions here. So pause the video, try all 3 of these, and then come back to check your answer. Okay, for the first one, it was pregnancies. What a randomly chosen pregnancy will last less than 252 days. We're finding the probability, which means we find the area under the normal curve using normal CDF. I drew it out. We want to go from negative infinity to 252. So negative 1e99 to 252. The mean is 272. The standard deviation is 9. I got 0.0131. We want to find the probability that a randomly chosen pregnancy will last more than 252 days. So I shaded to the right of 252. So it's normal CDF. Lower boundary is 252, upper boundary is infinity, 1e99, mean is 272, standard deviation is 9, and we got 0.9869. And last, we want to find the probability that a randomly chosen pregnancy will last between 252 and 298 days. I'm drawing this here. So normal CDF, the lower boundary is 252, the upper boundary is 298, the mean is still 272, and the standard deviation is still 9, and we get 0.9849. Here's another one with blood pressures. The Centers of Disease Control and Prevention reported that diastolic blood pressures of adult women in the U.S. are approximately normally distributed with a mean of 80.5 and a standard deviation of 9. What proportion of women have blood pressures lower than 70? Then we want to find the probability that a randomly chosen woman would have a blood pressure between 75 and 90. And last, we want a diastolic blood pressure greater than 90 is classified as hypertension. What proportion of women have hypertension? So pause the video, then come back to check your answers. Okay, so here are the correct answers. 0.1444. We go from normal CDF from negative infinity, negative 1e99 to 70. 80.5 and 9.9 are your mean and standard deviation. For the next one, we do normal CDF 7590, 80.599 and get 0.5421. And last, normal CDF 90 infinity, or 1e99, 80, and then 80.5, and then 9.9, and we get 0.1686. Alright, now let's talk about if we work backwards. Sometimes I'm going to give you, or we will give you, the area under the curve, or the proportion of the population, or the probability, and you will give the boundary or boundaries. Now we can use the table to do that, go backwards on the table. However, we're going to use the calculator, so let's skip that. So with the calculator, we're going to use the function INV norm this function here. It's found under second vars, but this time we choose number 3. Now, with or without prompts, you're going to be asked for an area. Make sure that you put in the area to the left of the number that you're looking for. Make sure it's area to the left. This means that you might have to, if they give you the area to the right, you might have to use the rule of complements to figure out what the area to the left is. And sometimes they give you the area in the center. And so you have to do a little bit of arithmetic to find out the area to the left. And then you need to follow that up with the mean and then the standard deviation. So INV norm, area to the left, mean, standard deviation is what you enter for this function in the calculator. And again, this function will find the boundary if I give you the area, or if I give you the probability, or if I give you the proportion of the population. So let's look at this example. A cherry tree in a certain orchard, or cherry trees in a certain orchard, have heights that are normally distributed with a mean of 112 and a standard deviation of 14. What proportion of trees are more than 120? So this is the normal CDF problem. So pause the video and actually go ahead and do the first 2 pieces, this one and this one. Okay, so the first one, normal CDF, 120 to infinity, 112, 14, we get 0.2839 as the proportion of trees more than 120. What's the probability that a randomly chosen tree is either less than 100 or taller than 125? So I found the area in the center and subtracted that from 1, so normal CDF, 100 to 125, 112, 14. Subtract that from 1 and we get 0.3722. So let's find the 27th percentile of the tree heights. And I'm going to go to a bigger screen. So 112 is in the center. Okay, so normal distribution, mean is 112, standard deviation is 14. We're finding the 27th percentile. So what that means, remember, percentile separates the bottom P% from the upper Q%. So let's separate the bottom 27%. So this here is the bottom 27%. And it separates that from the upper, the complement. So 1 minus 27 would be 73%. So we're looking for this boundary right here. We don't know what that is. Normally that would be the boundary, and we do normal CDF, negative infinity to this boundary with a mean of 112 and a standard deviation of 14, and that would give us the 27% or 0.27. But when we go backwards, we use INV norm. And we have to put in the area to the left of the boundary we're looking for. So this is the boundary we're looking for. The area to the left is the same as the percentile, 27%, but we need to put it in as a decimal. That's very important. So 0.27. The next comes, we don't need a lower and upper boundary. We just need the left area, the mean, and the standard deviation. So you only need 3 numbers. So the next number is the mean. The last number is 14. Alright, so we're going to do second vars number 3. The area is 0.27. The mean is 112, and the standard deviation is 14. And we get 103.42068182. For this kind of answer, when you're finding a boundary, I usually round to 2 or 3 decimal places. This is not a percent. It is not a proportion. It's not a probability. You're finding the boundary, so you don't have to round to 4 decimal places, and the number can also be bigger than 1. So 103.42. So the 27th percentile of tree heights is 103.42 inches. Okay, so we are going to end this video here. I know there's only one example left, but we're going to do a part 5 for normal distribution, and the only thing that we'll do in part 5 is this last example. Okay, so see you in part 5.